Hello guys, very good morning to all of you. In last lecture we have completed the buckling of column theory part. Okay. In today's lecture we will going on the numerical on buckling of column. See guys, here is one numerical is given on I section. This is the symmetrical I section. Okay. What is given in this numerical? You have given the simply supported beam. Okay, this simply supported beam is deflect from its original position when you apply this 50 kilonewton per meter load. Okay, this value is given in the first. There are two different cases are given. First is a I section used as a beam. Okay, at that time there is a UDL is at 50 kilonewton per meter. Okay, and this beam is deflect from its original position at 12 mm, and modulus is given 205 GPa. GPa means gigapascal is given. You have to convert it to MPa. How to convert it to MPa? 205 into 10 raised to 3 MPa, or you can write Newton per mm square. Then second case, we want to use that I section as a column, and they have given the end condition. This column end condition is given. Both ends are fixed. Okay, last lecture we have seen one table. Okay, in that table we have seen the actual length as well as the effective length. Both length we have seen, right? Actual length and effective length. Also we have seen the relation between actual length and effective length. If we have given the both ends are fixed, then what is the relation between LE is equal to what? L by 2. LE is equal to L by 2. This is very important end condition. Both ends are fixed. If you have given the both ends are fixed, then you should write LE is equal to L by 2. Then they have given the factor of safety, FOS is equal to 5, and what do we want to find out? We want to find out the safe load. Then how to calculate the safe load? Guys, remember, first you know what is the given in the numerical. Okay, then you have to write the given data and see what we want to calculate. How to calculate that safe load? It is denoted by PS. Okay, first we want to calculate the crippling load divided by factor of safety. This formula you will give the safe load value. Think reverse direction. Okay, what do we want to calculate? Safe load. How to calculate safe load? Here we get the crippling load. With the help of this given data, we get the PC load. Then factor of safety is given. With the help of you can calculate the safe load. Then how to calculate the PC value? How to calculate the crippling load? We know the equation. Last lecture we have seen pi square EI divided by LE square. Okay, think reverse direction. PC is equal to pi square EI divided by LE square. Again, we want to calculate the EI value. We don't know the EI value. Okay, E is given. We don't know the I value. I is the, what is the I? Least moment of inertia. Because here you will get the 2I. Moment of inertia above the x axis and moment of inertia above the y axis. You will get the two moment of inertia. That's why you have to calculate the least moment of inertia. Then how to calculate that least moment of inertia? We will see the details. Also we don't know the LE value. Then how to get this LE value? We will get this LE value. Check that here. In the first condition, here is this W value is given, load is given, but this length is not given. If we are using the case number 1, then we can calculate the length of the given beam. Once you have got the length, then you can put the LE value with the help of end condition. Both ends are fixed. L is equal to L by 2. Okay, getting how to calculate, how to find out the answer with the help of given numerical. Okay, first I will take the case number first. Okay, what is the case number first? I section is used as a beam. Okay, here I will use I section used as a beam. First we will calculate the moment of inertia. Moment of inertia. It is denoted by what? I. Ixx. Okay, Ixx. How to calculate in the third unit? We have already seen how to calculate the moment of inertia. Okay, this figure is symmetric. Check that. Put the x-axis. You will get the above that from the center or below the center. You will get the same mirror image. Then this given figure is a symmetric. Ixx is equal to, I will consider this is the outer part is a one rectangle. This one outer part is a one rectangle. Hence I will take the capital letters for this. BD cube divided by 12 is there, minus, and I will take this one hatching. I will show with that of hatching line. Check that this one is a small rectangle. Means this big rectangle minus this small rectangle divided by 12, you will get the value of Ixx. BD cube divided by 12 is there. Or you should again use the another formula, this plus this plus this. Okay, you know the moment of inertia for the rectangular body, BD cube divided by 12 is there. Okay, then I will put the value. What is the B for this? 240 is there. What is the D? D is equal to total D. This 40 plus 40, 80. 380 plus 80 is there. This 460. Check that. 460 cube divided by 12 is there. Minus this small b. What is the small b? 20 is given. 20 is given. Check this hatching line only. Minus or section 12. Sorry, 20 is there. 20 is there. 20 base is 20 into this distance. This distance is a 380. BT cube. 380 cube divided by 12. If you have calculated this, then you will get the Ixx is equal to 940.73 into 10 raised to 6 and then raised to 4. This first case you have given the Ixx value is equal to 940.73 into 10 raised to 6. What is the unit? Mm raised to 4. You have seen in the first lecture. Then what we will require? We require the EI value. The combination, or we can say the what we can say. We have seen in unit number 3. Flexural rigidity. What is the flexural rigidity? It is denoted by the EI. EI is equal to, put the value, E is given 205 into 10 raised to 3. Take that. I will write here 205 into 10 raised to 3 into what is the I value? 940.73 into 10 raised to 6. Okay. Also, I will write here unit. Check that. What is the unit of E? Newton per mm square. Newton per mm square into what is the unit of Ixx? Mm raised to 4. Hence you will get the value in Newton mm square. Newton mm square. If you have multiply this, then you will get the 1.92849 into 10 raised to 11 into 10 raised to 11. This is in, you will get the kilonewton. Okay, actually here you will get the 14, 10 raised to 14. This is in Newton mm square. Right, this mm square get cancelled and you will get the mm raised to 2 only. But we want to convert this value in kilonewton. And how to convert it to this value in kilonewton? 1.92849 into 10 raised to 11 kilonewton mm square. Okay, Again see, this value will required in meter. This value is given in meter. That's why again we want to convert into the kilonewton meter square. Then how to convert into the kilonewton meter square? You have to divide it by what? 10 raised to 6 or multiply by 10 raised to minus 6. Okay, 1000 mm is equal to 1 meter. Okay, remember that. Yes. Then you will get 192,849.65 this kilonewton meter square. This is the EI value. The conversion is very important. Okay, see what we required in which unit. Okay, we required in meter. How to convert this into the meter? Kilonewton meter square, because this value is given in kilonewton per meter. That's why I have converted into the kilonewton meter square. Okay, because you know the deflection. Again, unit number 3, third part we have seen deflection in SS, deflection in simply supported beam. SSB means what? Simply supported beam. Okay, what is the deflection when you add the UDL? When you add UDL on that simply supported beam, then there is a standard formula for the deflection. Deflection is equal to, it is denoted by the delta, then 5 divided by 384. Check that up. 5 divided by 384, WL square divided by EI. WL square divided by EI. This is the standard formula for that standard condition. We have seen the unit number 3 again. Okay, slope and deflection. Slope and deflection. Okay, then you should put the value in that equation. Check that again. Delta, what is the value of delta? Well, mm is there in it, but we have converted all unit in meter. Then how to convert this 12 into meter? Yes, anyone? 12 into what? 10 raised to minus 3 is there. Minus 3 is there, or divided by 10 raised to 3. That's why I will put here minus, 12 into 10 raised to minus 3 is equal to 5384 into, what is the value of W? 50 is there. 50 is there. Into, what is the value of L? We don't know the L value. We want to find out. What is the value of EI? 192849.65 kilonewton per meter square. Check that. We will take the unit also here. Meter is equal to, what is the value of that? 50 kilonewton per meter. Kilonewton per meter, right? Divided by this unit. Yeah, what is the unit of this? L square is there. Square is there. Meter is there. Meter divided by what? This kilonewton meter square. Okay, kilonewton meter square. Means this value you will get the in what? Kilonewton get cancelled. You will get the meter. This value you will get in meter only. Okay. Remember this equation, how to find out the units. Okay, this is very important. Then check that here we will get the L square. Here is the L raised to 4 is there. L raised to 4 is there. Okay. Then you will get the meter raised to 4 also. Means this you will get answer in meter only. Then check that if you solve this equation, then you will get the L is equal to 7.723 meter. L is equal to 7.723 meter. This value will get 7.723 meter. Yes, all of you getting how to solve this? Yes, then next one, what we want to calculate? Then again we want to find out the least moment of inertia. Okay, we have find out the we want to use here second condition and find out the least moment of inertia. I will take the case second. What is the case second? Yes, I section used as a column. I section used as a column. Okay. In the first case, we are using I section as a beam and find out the value of length. Then second, I will use here I section used as a column. What is the end condition? Before going on the end condition, you know, okay, we will use the end condition. Both ends are fixed. Both ends are fixed. Then what is the relation between the length? LE is equal to effective length is equal to actual length divided by 2 is there. Okay, you know this relation, remember that. Then put the value, already we have calculated 7.723 divided by 2 is there. Okay, you will get the 3.8604. Again meter is there. Okay. I will take this 3.86 meter is there. Okay, LE is equal to. Then again, if you want to convert into the mm, then how to convert? Multiply by 1000. Then you will get the 3860 mm. Okay, you know how to convert meter to mm, mm to meter, or kilometer to meter, then GPA to MPa. All these things you know when you solving the numerical. Then second, we want to calculate the moment of inertia about the section YY. Okay, this section, moment of inertia about the section YY. Again, this is the symmetric. Okay, then how to calculate that moment of inertia about the section YY? I will consider this is the first part, this is the second part, and this is the third part. Okay, this equation will change. When you calculate the IYY for the symmetric section, then you will get the dB cube divided by 12 plus for first part, then second part dB cube divided by 12 for the second part, plus third part dB cube divided by 12 is there, third part. Okay, when you see this first part and third part are same. Okay, you can also write 2 into dB cube divided by 12. 2 into dB cube divided by 12. And I will write here d. What is the d? D for the first part, 40 is there. What is the b? 240 is there. Divided by 12. Plus second part, what is the d? 380 is there. What is the b? This one 20 is there. Divided by 12 plus third part again same value. What is the d? 40 into 240 cube. 240 cube divided by 12 is there. Check that. When you solving this value, you will give the IYY value. IYY. When you solving this, check that first and second value are same. When you calculate, then you will get the 92.41 into 10 raised to 6 mm raised to 4 is there. You will get the IYY. Check the value of IXX. What is the value of IXX? Already we have found out IXX value. Yes, anybody? IXX is equal to 940.73 into 10 raised to 6 mm raised to 4. And which is the least value? Check that. Which is the least value? Least means small value. Okay, you have to choose the small value. This IYY is equal to I list is equal to 92.41 into 10 raised to 6 mm raised to 4. Okay, you have to use this value in this equation when you find out the PC value. Okay, then next step is we want to calculate what you have calculate the IS value. Okay, then we want to calculate the crippling load. PC is equal to, we have all the value, and calculate PC is equal to pi square AI divided by LE square. What is the pi square as it is? Then EI, we have calculated the EI value. What is the EI value? 192849.65 into divided by this value we have calculated, okay, in kilonewton meter square. Then LE square, what is the LE square again? 3.86 is there, na? Check that. PC is equal to, there is a 3.3860 square is there. So check that value, you will get the same value. Yes, check that. This is the 92.41 into 10 raised to 6, 192. This value we have calculated in kilonewton meter square, but here we have taken this mm square. That's value we have calculated in kilonewton mm square. What is this value? 1.98, yes, 1.92849, right, into 10 raised to 6 is there. Check that. This value we have calculated in kilonewton meter square. I will check once again what value we have calculated. This value is correct or not? Okay, this ISX is equal to 92.46 is there. Okay, sorry, this is EI value. EI value, check that. 92.46 is there. 92.41 into 10 raised to 6 is there. Which value? We have calculated EI value, not only E is given, I is given. Already we have calculated. Okay, this value EI. Then check that what is the value of PC. PC is equal to, you will get, when you calculate this PC is equal to, you will get 12.55 into 10 raised to 6 Newton. Okay, all of you getting how to calculate? Because already we have calculated, we have erased, that's why we don't have this value. I have checked, this is the correct value, 92.41 into 10 raised to 6. Okay, once you have got the PC, then check that how to calculate the PS. PS is equal to PC divided by factor of safety. 12.55 into 10 raised to 6 divided by, what is the factor of safety? 5. Then you will get, what you will get, the PC is equal to, I will check that, PS is equal to 2509.7. 2509.7. This value you will get the kilonewton. This is your answer. Okay, this is the first numerical I have completed. Guys, half part up to that we have learned unit number 3. Only this is new thing is that PC is equal to pi square EI divided by LE square. Means you have to take the reference of unit number 3, how to calculate the moment of inertia, how to calculate the neutral axis position. All these things we have seen unit number 3. Okay, today we will stop here. Next lecture we will see again new numerical on the unsymmetric section with the help of buckling of column, how to solve that given numerical, or how to calculate the crippling load or shape load, or we can say the crippling stress. This type of numerical we will see in the next lecture. Thank you.